All right, so what's the first step in completing the square? What should occur in the first step? But even before you do that, you could move the constant right now. That is true. You can do that. But what do you want the coefficient of x squared to be? 1. You want the coefficient of x squared to be 1. It is not 1. So what is it that you have to do to both sides? Divide both sides by 5. All right, so I'm going to divide both sides by 5. So I'm going to do it like this. Divide by 5. What you do to the left side, you have to do to the right side. All right, now we talked about the fact, you see how you have all these terms being divided by this monomial? So I can break it down into fractions, 3 separate fractions. So what's 5x squared divided by 5? X squared. What's a negative 10x divided by 5? Okay, and then what's 2 divided by 5? 2/5, and that's going to equal 0. All right, so that's where I'm at. So the one on that previous worksheet, those were easier to deal with because all of these terms didn't have any fractions in it. The one in that previous worksheet. This one does now. Okay, so now what's the next step? If you recall the steps you had to perform. All right, subtract 2/5 from both sides. I know this is going to be challenging. So x squared minus 2x leaves some space, and that's going to equal what number? Negative 2/5. That's correct. All right, so that's where we're at. Okay, at that point, what was the next step you had to do? Take the coefficient of -2 and do what to it? Divide it by 2. All right, so I'm going to go ahead and take the coefficient of -2, divide by 2, and that's going to equal what number? -1. Okay, so that's going to equal -1. Now, what do I do to that -1? I got to square that. And when I square it, what do I get? Positive 1. All right, once I get that positive 1, what do I then do to that positive 1 right here? And it's always going to be positive. You add it to both sides. So it's always going to be a +1 or a plus whatever. It's always going to be adding something. Now, if you did this correctly, the left-hand side should be a perfect square trinomial, which means I can factor this as a binomial squared. And I can. How can I factor this? X minus 1 times x minus 1. Or x minus 1 what? Squared. Okay, now let's look at the right side. Now, this is where you have to do some work. So I have a -2/5, plus 1. On the previous worksheet, it was easy because it's just an integer. Here it's not an integer any longer. It's a rational number that's represented as a fraction. So remember how to add fractions? You got to find the LCD, which is 5. So -2/5, and remember 1 is 5 over 5, right? Yeah. All right, so what's -2/5 plus 5/5? 3/5. So now that goes here. So that's equal to 3/5. So you have to use some things that you learned many years ago, and that is adding fractions with unlike denominators. Now, you have access to your calculator. If you know how to use your calculator and get a fraction from it, then go ahead and do that. Okay, now, at that point, what was the next thing you had to do? Remember, this is on your test next week. What was the next thing you had to do?
Square both sides.
Not square both sides. He's doing this. What is that? Square root. You take the square root of both sides. All right, so I'm going to go ahead and rewrite this over. All right, now remember, when I do the square root of both sides, what else do you need to put there? Plus or minus. The left side should be easy. What expression is on the left side? X minus 1, because the square and the square root undo each other, so it's x minus 1. Equal. All right, now you got to remember something from last semester, Math 99. So I have the square root of 3/5, correct? Mm-hmm. Okay, so square root of 3/5. I'm going to go ahead and talk about that here. Okay, so I have the square root of a fraction. You can always rewrite the square root of a fraction as the square root of the numerator divided by the square root of the denominator. The same thing. So the square root of 3/5 will be the square root of 3 divided by the square root of 5. That's what that is. Okay, now, you also learned that the square root of 5, that denominator, is an irrational number. I mean, we talked about that at the beginning of the semester when you found your solutions. Remember we talked about whether they were rational or irrational? So square root of 5 is irrational. So you may remember this phrase I'm about to say. I'm going to go ahead and rewrite this over. Rationalize the denominator. So you may remember that phrase. All right, so rationalizing the denominator means make the denominator a rational number. The square root of 5 is what kind of number? Irrational. So if I want to make that denominator a rational number, and for us the rational number in the denominator I'm looking for is a whole number, like 1, 2, 3, 4, 5, and so on. That's what I want the denominator, a whole number. Do y'all agree? Do y'all agree that I can end up having this right here be a whole number if I were to multiply both numerator and denominator by the square root of 5? So remember, if all I have is a square root of a number in the denominator, to rationalize it, I just multiply numerator and denominator by that denominator. Because what's the square root of 5 from the square root of 5? 5. Is 5 a rational number? Yes. So what's the numerator? Square root of what? What's square root of 3 from square root of 5? Square root of 15. What's the denominator? 5, so it's now a rational number. So that goes here, plus or minus the square root of 15 divided by 5. And then all you do is just get x by itself. So how do I get x by itself? Add 1 to both sides and you're done. You can leave your answer like that. So you can say x equal 1 plus or minus the square root of 15 divided by 5. All right, so let's kind of review rationalizing the denominator. Rationalize the denominator. Okay, rationalize the denominator. Suppose I had, let's say the square root of 7 divided by the square root of, let's say, 10. The denominator is what kind of number at the moment? Irrational. Rationalize the denominator. If you remember that phrase from last semester, or whatever course you may remember it from, means to make the denominator a rational number. Square root of 10 is not a rational number. Square root of 10 is an irrational number. Well, you remember that if I want the denominator to be a whole number, a rational number, I just got to multiply by itself. Square root of 10, because it's just one term. What's square root of 10? Square root of 10? 10. It's a rational number. But what you do to the denominator, you got to do to the numerator. And so this becomes, so the square root of 7 divided by the square root of 10 becomes what expression? Square root of 70 divided by 10. Now don't make the mistake and simplify 10 and 70. Don't say the square root of 70 divided by 10 is the square root of 7. That's not true. You can put that in your calculator and see those are not equal to each other. You're trying to remember that if I had 70 divided by 10, that is what? 7. But that's not 70. The square root of 70 is not the same as 70. So you cannot reduce like this. This square root of 70 does not mean 70. Those are two different numbers. I mean, the square root of 100 is 10. So obviously this is less than 10, right? This is 70 right here. It looked like a 10. That's 70. Okay, so that's rationalize the denominator. Now, it could also be where you could have something like this. Number 2, let's say you had 5 divided by the square root of 6. How would you rationalize that denominator?
Multiply square root of 36.
Multiply the numerator denominator by
Square
square root of 6. That's the only way. Well, that's one of the ways, not the only way. That's one of the ways to get that denominator to be a rational number. And so my numerator is just what though? 5 square root of 6. Don't say square root of 30, because that's not the square root of 30. It would be the square root of 30 if this was the square root of 5. Okay? And that's divided by what? 6. All right, so that's a quick review of rationalizing the denominator. Now, my math lab, actually there's not one like this in my math lab. So I don't think there is. All right, but if there is, my math lab, they're going to want you to separate the solution, so I'm going to just use those commas. All right, let's look at another one. Now, before we look at another one, let's kind of review this from a long time ago. All right, so if I say take half of, let's say, 8. Obviously, that's easy. What's half of 8? 4. So you could do one or two things. When you say take half of 8, you could take that number and divide it by 2, or you can multiply by what? You use a fraction. Don't use a decimal. 1/2. That's what take half means. So take half of 1/8. I can say 8 divided by 2, which is 4. Or I can say 8 times a half, which is also what? 4. Okay? Now, what if I had this? Take half of 3/5. Take half of 3/5. Same thing. I could take half of 3/5 means either I divide by 2 or I multiply by 1/2. So if I multiply by 1/2, let's do that first. If I multiply by 1/2, I get 3/5 times a half, and then try and reduce if you can. I can't reduce here. So what's 3/5, or what's half of 3/5? 3/10. Or I could take 3/5 and divide by 2. Now you may remember that part from Math 97, from 3 semesters ago if you took that course. How do you divide fractions? You multiply by the reciprocal. So you take the fraction that's in the numerator, which is 3/5, and you multiply by the reciprocal of the number that's in the denominator. So what's reciprocal of 2? What's reciprocal of 2? 1/2. Isn't that what this is right here? So you get what number? 3/10. All right, that's going to be important with the second problem we're going to do. All right, so let's look at number 2. So number 2. So let's suppose we had this quadratic equation, and you want to solve this by completing the square. Now, the one in your test Saturday, the quadratic equation will have the x squared term will have a coefficient of 1. This does not. All right, so suppose we had 6x squared plus 5x minus, let's say I'm going to use 12 equals 0. So 6x squared plus 5x minus 12 equals 0. All right, so I want to solve this by completing the square. What's the first thing you're going to do? Say it again?
Add 12 to both sides.
You can add 12 to both sides. What could someone else have done first? Divide both sides by 6, the coefficient of x squared, because you need x squared to have what coefficient? 1. So 6x squared divided by 6 is x squared. And then over here I get 5 divided by 6x, right? And then minus, what's negative 12 divided by 6? And that's going to equal 0. So that's where we're at. What's the next step? Add 2 to both sides and leave some space. So I get x squared plus 5/6x. I'm leaving some space equal what number? 2. Okay, it's equal 2. Okay, now what's the next step?
Multiply 5, 6, 5.
All right, so I take the coefficient of x, which is 5, 6, and that's where you take half of that. Remember that? So we just talked about how to take half of 5, 6. So take half of 5, 6. Let's just go ahead and multiply by 1/2. That's probably the easier thing to do rather than dividing by 2, because you end up with this anyway. What is that? 5/12. Now, once you get 5/12, what do you do with that 5/12? I've got to square that. And when I square that, what's 5/12 times itself? 25 divided by 144? What do I do with 25 divided by 144? What's the next step? You had that on a previous worksheet, those steps added to both sides. Equal, and then 2 plus 25 divided by 144. So that's where we're at. Okay. If I'm doing this correctly, if my steps are correct, the left trinomial should be what kind of trinomial? What's the word? Perfect square trinomial. Meaning that when I factor it, it's a binomial squared. All right. Now some of you have a habit of just putting something in there and not checking it. What do you think goes? What binomial do you think goes inside that parentheses? X plus 5/12. Remember in previous lesson when we talked about this, when we had the easier problems, we said whatever you see here should be here. So this should be x plus 5/12. Now before we go on, double check to make sure that's true. Now in the previous problem, the binomial is x minus and this one is x plus. So just make sure you know when this is going to be x minus, when it's going to be x plus, because that sign here takes this sign here. In the previous problem, this was x squared minus the x term. Okay, before we go on, make sure you see that this is actually this. You may say, well, how do you get 5, 6 from here? All right, well, let's check. X plus 5/12 times x plus 5/12, right? FOIL it out. What's x times x? What's the outer? 5/12 x. Remember, when you square a binomial, the out and the inner are the same. So the inner should also be what? 5/12 x. And then what's the last? What's 5/12 times 5/12? 25 over 144. So that kind of makes sense there. That whatever you put here, when you square it, you better get this number, right? So you may say, well, how do I know if I got 5, 6? Well, what's 5/12 plus 5/12? 10 divided by what? Oh, girl, not 24. 10 divided by what? 12. It's okay. That's all right. We all say something like that once in a while. That's fine. Now, what's that reduced? Was that reduced? 5, 6, which is what this was. Okay. So did I factor it correctly? Yes. All right, now let's go to the other side. So I got to somehow figure out what 2 plus 25 over 144 is. So 2, I'm going to do that here. 2 plus 25 divided by 144. Remember when adding, now this is a whole number. Um, when adding a whole number and a fraction, you can just automatically write it as a mixed number, couldn't you? So there's a couple ways you could do this. 2 plus 25 over 144 is what mixed number? 225 over 144. So whenever you're adding a whole number, that's adding. If you're subtracting, that's a little different. But for our case, we'll be adding anyway, right? Because when you square that number, you add it to both sides. So it'll always be plus some fraction in this case. And then you just got to rewrite this back as an improper fraction. So how do you write a mixed numbers in improper fraction? 144 times 2, which is 200. Use a calculator. 288. And what's 288 plus 25? 313. I'm just writing what y'all saying. Or 144, right? Okay. The other way is to actually find the LCD. That's the other way. But you need to rewrite that 2 as 2 divided by 1. Okay, what's the LCD? 144? All right, now the next step is to write equivalent fractions. Well, these fractions here that I'm pointing to, they already have the same denominator, so that means the numerators have to be the same. Now let's talk about this one. I have a 1, I need to be 144, so what do I need to multiply that by? What I do to the denominator, do to the numerator. What's 2 times 144? 288, which is what we had here, right? And so it's 288 plus 25 over 144. 313 over 144. All right, so multiple ways you could have done that. Now that goes here. Okay, so that goes here. A couple more steps and you're done. So you did the hard work, although it really isn't hard. It's just you trying to remember something that you've learned a while back. What's the next step at that point? You gotta solve for x. Take the square root of both sides. And then what else should you do? Plus or minus. The square and the square don't do each other, so what's my expression on the left? Equals plus or minus. Now, you see you're taking the square root of a fraction, so that's the square root of the numerator, so the square root of 113. The denominator, when you complete the square, in this particular situation, the denominator is always going to be a perfect square, by the way. So what's the square root of 144? 12. So my denominator will always be a perfect square when we go through this process. So if you do the one in the worksheet, when you get to number 2, you're going to see that the denominator is a perfect square. It's always going to be that way because what are you doing here? You're squaring it. So when you square a number, that number is a perfect square. And then all you do is bring this 5/12 to the other side and you're done. So I get x equal negative 5/12 plus or minus the square root of 313 divided by 12. So you can leave your answer like that. That's fine. My math lab, you would, again, I don't think I signed those kind of problems. But we need to go over because we're about to do circles again, which involves completing the square that we're about to do. And so you are going to at some point have fractions. Okay, so that was a review of completing the square, but in this situation, we ended up with fractions in the process. Okay, so